All right, today we are in Unit 5, Lesson 6, again coming out of Chapter 11 from the textbook. The topic of our lesson is confidence intervals and hypothesis testing. We have two content standards that are the focus of this lesson. The first one is understand statistics as a process for making inferences about population parameters based on a random sample from the population. And the second one is use data from a sample survey to estimate a population mean or proportion. Develop a margin of error through use of simulation models for random sampling. Our mathematical practice, that's the focus of our lesson, is number 7, look for and make use of structure. We're going to start off with a key concept on how to find the error estimate. The error estimate E for a population mean is given by the formula Z times the S over square root of N, where Z is a value that corresponds to a particular confidence level. There's multiple ways of finding this, whether on the calculator or by hand. S is the standard deviation of the sample, and N is the sample size. And it's important to remember that N needs to be at least 30. So our first example is on oral hygiene. It says a poll of 422 randomly selected adults showed that they brushed their teeth an average of 11.4 times per week with a standard deviation of 1.6. Use a 99% confidence interval to find the maximum error of estimate for the number of times per week adults brush their teeth. So if we want to find an error estimate, the first thing that we want to do is find our z-value. So if we have a 99% confidence interval, that means that there's 99% of our data within the interval, and there's 1% of our data that's outside the interval. And because there's 1% outside, there's going to be 0.5% in each tail. There's going to be half of a percent on the upper tail and 0.5% on the lower tail. So the way you find the z-value, they just tell it to us here. It's 2.576, but I'm going to pull up my calculator and show you how to calculate this. So in order to find out z-scores, knowing a confidence level, you need to go to second bars and then choose an option number 3 for inverse norm. The area that we're going to pick is the area that's in one of the tails. So if we know that there's 0.5% in each tail, that's 0.005. You're going to leave the mean as 0 and the standard deviation as 1 because that's the standard normal distribution information. And then we're going to hit paste. And we get the number negative 2.576. This rounds to 576. So basically, the z value is 2.576, and if it's on the left side, it's negative. If it's on the right side, it's positive. But the key is that the value is correct. So we have 2.576 for our z-value. So then we're just going to plug in the sample standard deviation that we're told and the sample size, plug that in, and we get an error formula. The maximum error is about 0.20. So the explanation for what that means is that you can be 99% confident that the number of times per week that adults brush their teeth will be within 0.20 of the sample mean of 11.4, meaning that 99% of adults, or 99% confident that the true number of times that adults brush their teeth per week is between 11.2 and 11.6 times per week. So here's a check your progress problem, pretty much same style. This time we have a 95% confidence interval. So if there's 95% in your interval, there's 5% outside your interval. So you need to figure out how much would be in each tail to total up to 5% in order to find your z-value for this problem. So go ahead and pause the video and work it out. And when you have your answer, go on to the next slide. Okay, our answer for check your progress number 1 is C, 0.96. Next, we have the key concept on what a confidence interval for a population mean is. So confidence intervals are just a way of expressing how confident you are that the true population mean is within a certain range, and you're estimating the population mean by knowing a sample mean that's given in the problem. So you're basically taking your sample and you're extrapolating it. You're pushing it out to look at, can we generalize something from a sample to the entire population? So our formula for a confidence interval is x bar plus or minus e. And x bar is your sample mean, and you're going to add the error estimate and subtract the error estimate to the sample mean to get your confidence interval. And remember that e is just z times the sample standard deviation divided by the square root of the sample size. So example 2 says a poll of 156 randomly selected members of a golf course showed that they played an average of 4.6 times every summer with a standard deviation of 1.1. Determine a 95% confidence interval for the population mean. So we're going to use our confidence interval formula, x bar plus or minus z times s over square root of n. We need to find our z value, so I'm going for 95%. So again, I'm going to come over here, second bars, choose option 3. This time we had 95% confidence, which means that there's 5% outside of our interval, and looking at one tail, that would mean there's 2.5% in each tail. So the decimal way for 2.5% is 0.025. We're going to go down and paste that in, and we get negative 1.96. And you can see that's how they got this number here of 1.96. The other numbers are just numbers that were given in the problem. 4.6, average is the average sample. Standard deviation, that's given. 156, that was given. This is basic algebra, you're going to get 4.6 plus or minus 0.17. So then you're going to take the 0.17 and you're going to add it and subtract it from 4.6, which means that our 95% confidence interval is, for the population mean, is all numbers that are between 4.43 and 4.77. So we are 95% confident the average number of times played per summer is between 4.43 and 4.77 times. Okay, here's check your progress. For example 2, this time you're looking at 90% confidence. That means there's going to be 10% outside of your interval and 5% in each tail. So go ahead and pause the video and work this one out. When you have your answer, go on to the next slide. Okay, answer for check your progress number 2 is B. The population mean estimate is between 6.62 and 7.18. All right, example 3, we're going to be looking at claims and hypotheses. Before we get into this, I just want to point out that the way this is explained here is different from the way that claims and hypotheses are explained in AP Statistics. I don't necessarily think the way they explain it here is the clearest way possible, but it's not incredibly different from AP Stats. It's slightly different. But if you take both of those courses, then you'll see what the difference is, and hopefully you'll see that it's not a huge difference. It's just something that, as a teacher, kind of annoys me, the fact that they teach it a little bit differently in different courses. So example 3 says that we need to identify the null and the alternative hypotheses for the statement, then identify which statement represents the claim. So a null hypothesis essentially is what's already been happening or what the default value is in some scenario. And an alternative hypothesis is, well, what are they wondering, if you do some experiment on it, if you do a treatment, does that improve the null hypothesis? Does it improve the null hypothesis amount? Does it lower it? Is it different? Like, how is it changing? That's what an alternative hypothesis is. So part A of this problem says that Cindy thinks her employees spend over 90 minutes per day surfing the internet at work. Over 60 minutes per day, sorry. So when they say over 60 minutes, that means that the mean amount of time per day would be over 60. The opposite of that would be not over 60 minutes, which means it could be less than or equal to 60 minutes. And the way that they want you to do these problems is to find whichever thing has an equal sign in it, that's your null hypothesis. So the claim here is whatever the person thinks is going on. So Cindy thinks her employees spend over 60 minutes, so that's the claim. The claim is that the mean is over 60. And that's the alternative hypothesis because it does not have an equal sign in it. The null hypothesis is always going to be the thing that has the equal sign in it. So that's less than or equal to 60. And they say which is the complement, which means opposite of the mean being greater than 60. So the way that what they have written here, H with a subscript of 0, that's how you say the null hypothesis. Null is an older way of saying nothing or 0. That's why they use hypothesis 0. And then the alternative hypothesis, they use a subscript of the letter A for alternative. So when you write your hypotheses, you need to be able to express them using this terminology. Part B of example 3 says, Mr. Bacon thinks that he tells at least 5 jokes every class period. So again, this time, if Mr. Bacon thinks he tells at least 5 jokes, at least means greater than or equal to. And then the opposite of that, not at least, would be less than 5. So his claim is that he tells at least 5 jokes. The claim is mu greater than or equal to 5. And that's the null hypothesis this time because it includes the equal sign. And the alternative hypothesis is the opposite, which is that the mean is less than 5. And so again, on this side, we're going to see how to write the hypotheses with the correct format, the variables. H naught, the null hypothesis is that mu is greater than or equal to 5, and the alternative hypothesis is that mean is less than 5. All right, check your progress for example 3. Go ahead and pause the video, work out the problem, and when you have your answer, go on to the next slide. Here, our answer for check your progress number 3 is choice D. The null hypothesis is that the mean is less than or equal to 14. That's how you say no more than. And the alternative hypothesis is that the mean is greater than 14. All right, next we have a key concept on significance tests. There's different kinds of tests that we can run. So far we've only looked at like a one-sided test with one tail. You can also have two-tailed tests, and there's a difference between a left side test and a right side test. I don't know if you remember back earlier in the video when we did the inverse norm commands to find the z-scores, we always did a left tail. If we had done the right tail, we would have had the same number over here on the right side. It just would have been the positive value. The key is that the critical region is any value that's outside your z-score. That's like on the left side, if any number that's below your z-score. On the right side, it's any number that's above your z-score. And on a two-tailed test, it's any number that's above or below the z-score that you get. And this time the critical region is divided by 2 because there's 2 tails that have to add up to your total amount. There's a 5-step process for how you run a hypothesis test. The first step is that you need to figure out what's the claim, what are they claimings going on, and then come up with hypotheses. The second step is to figure out your critical value and your critical region. Then you're going to calculate the z-statistic using the formula x bar minus mu divided by s, the sample standard deviation, over the square root of n. Step 4, you need to figure out, based off this z-value, do you reject the null hypothesis, or can you not reject? Do you fail to reject the null hypothesis? And then finally, you're going to make a conclusion about the claim. Do we reject the claim? Is the claim correct, or is the claim wrong? We're going to go ahead and pause the video. We're running out of time. We're going to pick up with example 4 in the next video.